What makes two players the same? Usually, people use the eye test to compare goal scoring ability, chance creation, or dribbling style to answer this question. But in this video, we will take a more scientific approach and blend math and data analytics to come up with the answer. Let's talk about the details on how we can find similar players. Though we will want to compare them across several metrics, let's start with just one to build our intuition. Let's say we want to compare players based on the number of goals that they have scored. We can visualize how similar players are in terms of this metric by plotting their goal values on the number line. Looking at the 24-25 La Liga season, for example, we see that Lamine Yamal had 9 goals while Mbappe had 31. The total number of goals, though, doesn't create a fair comparison. Let's say that a player was injured for a good majority of the season, or that they usually get subbed out. These players would then unfairly be deemed to have less goal scoring output compared to other players. However, if we instead use per 90-minute goals, then we can fairly compare players' goal scoring ability without worrying about the number of games played or substitutions. As we can see here, Bellingham has a slightly larger value for per 90-minute goals, because even though him and Yamal scored the same amount of goals last season, Bellingham did it in 4 fewer games, so his efficiency is slightly higher. Because of this example, we can see that using per 90 metrics is much better than just raw counts, which we will do going forward. So, how do we see how similar these players are in terms of this metric? Well, the per 90-minute goal values between the players become more similar when the distance between their values becomes smaller. This distance can be found by subtracting the two values and then taking the absolute value to ensure that the result is not negative, as distances should be. In general, for any player combination, the formula for finding the distance will be to subtract the two per 90-minute goal values, which we will call x1 and x2 from each other, and then take the absolute value. Now, what if we want to compare across two metrics, per 90 progressive carries and goals plus assists? The idea is the same. We need to find the players that have the smallest distance between them, but we are now in 2 dimensions instead of 1. So the point that represents our player has a fancy name called a vector. The tip of the vector is the point that we land at by going right and up the appropriate amount of units. In this example, we go right 0.69 units on the x-axis and then up 5.7 units on the y-axis, since these are the per 90 goals and assists and progressive carries that Lamine Yamal had last season. So now that we know how to represent our points for each player, how can we find the distance, aka the similarity between the two? The formula is actually given by the Pythagorean theorem. We will take the two players' per 90 goals and assists and subtract them from each other and then square that number. We will also do the same thing for the per 90 progressive carries. Finally, we add those numbers up and take the square root of the final result. This gives us a distance of 1.12. To do this in general for any player, the process is the same. If we let x1 and x2 represent the per 90 goals and assists, and y1 and y2 represent the per 90 progressive carries, our formula is given as shown. So the next time somebody tells you that the Pythagorean theorem is useless, you can at least show them this example and let them know that multi-million-dollar decisions are made using it. Now, going from 2 to 3 dimensions is not that much different. You just get one extra set of numbers for each player, so the distance just adds an extra term in the distance formula, as you can see here. And in general, this holds for 4, 5, 6, and as many metrics as you want. Now that we showed the theoretical groundwork, let's move on to the results. But first, a quick word from our sponsor. Just kidding, no sponsor. So let's get on to the results. We'll start with the least similar and get closer and closer. So first we have Casemiro at 1.03 distance. Then we get closer with Lukaku. Then Dybala at 0.5. Then Salah. And finally we have Saka, which is the most similar, with a distance of 0.15. When we look at this spider or radar chart, we can see just how similar these players are, though the actual metrics that I matched on don't come from the chart on the left, but actually the boxed values on the right. And the reason is I didn't have all of the data that's available on the spider chart, but the data that I did have and I used, I believe, is sufficient to actually capture player similarity. The reason is that the 3 progressive metrics capture how a player advances the ball by dribbling, passing, or off the ball movement. The non-penalty goals and assists reflect actual end product without a penalty boost, and the non-penalty XG and assists reflect the quality and volume of attacking chances that are created. Now, what happens if we put an age filter where the players have to be the same age or younger as Lamine Yamal? Now we can see some interesting results of rising stars. So we'll start with George Ilinikina at 1.15 distance. Coming closer is Ethan Nwaneri, and then just edging him out is Yan Diomande as the most similar player with that age cutoff that we were talking about. If we compare the distance of Yan Diomande and Saka to Lamine Yamal, though, we can see that Saka was a much closer match with a distance of just 0.15 versus 0.74. So a player that is very similar to Lamine Yamal at the same age or younger shows to be pretty hard to find. And this makes sense given how rare of a talent he is. Now, why is finding similar players useful? Well, clubs can use this information to buy either cheaper and or younger talent for a certain style of player. Whether they develop that player to sell for a higher price tag or try to keep them for the long term is up to them. However, using data to make a more informed decision is crucial. Now we can pivot to players similar to Ronaldo and Messi. The data I used here is comparing players from the 24-25 season to Ronaldo and Messi from the 17-18 season. And first we will start with Ronaldo and actually look at players that were 21 or younger. We can see that at first place we had Bradley Barcola, second place is John Rowe, and third place was Lamine Yamal. Now, if we drop the age restriction, then our top 3 become first place is Salah, second place Barcola, and third place Gnabry. And now we can pivot over to Messi. So with the age restriction, the top 3 are Cherki, Doué, and Barcola. And if we remove the age restriction, then the top 3 most similar players become Dembele in first, Cherki in second, and Olise in third. One player that stood out in this whole analysis was John Rowe. He was in the top 3 of the under 21 players that were similar to Ronaldo's 17-18 season, and was also quite similar to Lamine Yamal last year, though he was not in the top 3 most similar. Regardless, he stands out as a perfect use case of using such a similarity algorithm. He is still young, relatively cheap, and shows early signs of great potential, as we can see in these highlights, though his dressing room scuffle may be off-putting to some clubs. That's the end of this video, and we now know how using some data analysis and math can help us find player similarities. There's a lot of technical details that I glossed over here, but please let me know in the comments if you'd like me to dive into anything more specifically. A couple of things to note about the data is that it only included league games in the top 5 European leagues, so players from the Argentine, Brazilian, or other leagues would have been missed in this data, along with performances internationally and in the Champions League, for example. But that's it. Please let me know in the comments if you'd like me to dive into anything more, and please don't forget to like, comment, and subscribe. Thank you. Like a lighthouse, I've been shining through the darkness. Christina Aguilera with the genie in a bottle. Hope this message keeps you well afloat. Flowing like the ocean, put the wind up in my sails just like a pirate. Then I hit the road. Capping like I'm